The spread operator allows us to easily copy arrays and objects. This is important because in TypeScript, we typically follow a principle of immutability. What that means is we do not want to mutate data directly. For example, sometimes we want to add an element to an array. Typically, the way we do this is with the push method. However, that will mutate the original array. To do this without mutating the original array, we can use the spread operator. I wrote up some simple code that you should be familiar with. We create an array, we add an element to the end of the array, and then we print that array to the console, and we see that we have mutated the original array by adding a new element into it. Now you might be wondering, why is this such a bad thing? And in some cases, there's absolutely nothing wrong with this. However, once we get into more advanced use cases, especially once we get into React, the concept of immutability is going to be very important. See, sometimes we want to be able to observe an array, and if that array changes, we want to make certain updates based on that change. Now, if we mutate the array directly, it's really hard for us to detect if something changed. However, if we have an entirely new array, it can be very easy to detect that change. So to do this in an immutable way, where we add an element to the end of the array without updating the original array, we'll use the spread operator, and the syntax for that is going to be 3 dots, and the array that we want to copy over. Afterwards, we can add additional elements, such as -3, or you could really add as many additional elements here as you want. Or perhaps you just want to copy the array and not change anything. You could just do ... ARR, with no other elements, and that would just copy all of the contents from the original array into the new array. I added some log statements, ran the code, and we'll see that when we log the original array has been unchanged. When we log the new array, it has all the contents from the original array, plus the new element we added. I've also console logged ARR == updated array, as this would be a very easy way to see if the objects are the same in memory or different in memory. And in this case, we can see that it printed false to the console, as array and updated array are different arrays in memory. Now the spread operator can also work on any object, not just arrays. And to illustrate the spread operator on objects, we've defined an object, some flashcard. That flashcard has a string to represent the front side, a string to represent the back side, an owner, and some collection that the flashcard belongs to. Now I've gone ahead and I've added code to update the front of the flashcard based on how we previously learned to do so. And once again, in certain use cases, this might be totally fine. However, I want to reiterate that this is mutating the object. And when we make updates to an object in this way, it's very hard to detect if an update has happened. The reason being is that we can't just see if it's a different object in memory, we actually have to inspect all of the fields of the object to know if anything has actually changed. So now I've gone ahead and added some code, which uses the spread operator to update the flashcard. For using the spread operator in objects, once again, we're going to use 3 dots, and then we'll provide the object that we want to copy the contents from. This will go ahead and copy all of the keys and values from this object into the new object that we're creating. Then we can optionally provide additional key value pairs to either add additional fields or overwrite the existing fields that would have been copied over. I ran the code, and we can see that the original flashcard has been unchanged, and the updated flashcard is an entirely new object, which has all of the same fields copied over, but we've overridden the property for the front of the card. And then once again, I use the == to illustrate how easy it is to compare if two objects are different. If what I was saying about immutability doesn't make sense right now, that's probably okay. What I want you to know for now is what the spread operator does. I'll be using it fairly commonly in the future, and I'll definitely reiterate the importance of immutability when we get to scenarios where it matters the most.